Okay. So, Brandil, have you to Deepak for online?
Yes, ma'am. I have informed him, and I have also sent the means the backdrop and the
Okay, okay, okay. So you yellow. Good evening, everyone. Welcome to the online technical talk done by the IEEE Signal Processing Unit student branch from KIIT University. Today, we are privileged to listen the talk from our guest, Dr. Ayasha Rath. Ayasha Rath is currently working as an assistant professor in Department of Computer Science and Engineering of C.B. Raman Global University, Odisha, India. She has teaching experience of 5 years and research experience of another 3 years. She has awarded with her PhD degree in computer science and engineering, development of intelligent models for efficient detection of heart disease from Shiksha on deemed to be University Odisha in April 2023. She has number of publication in various journals, around 24 papers in various international conference, book chapters and patents, and one book. She is continuing 4 PhD students under her guidance. On February 19, 2026, her number of citations are 649 H index, index of 13, and I index of 15. She consistently excellent academic record and received gold medal in 2019 for securing first position in MTech Computer Science. She also has received the Young Technocrat Award on September 15, 2020. She is IEEE member. Uh, she is working in where in basically in medical science applications area. She is regular reviewer of many international journals. She acted as a session chair in many of the international conferences. Her research interests are in the areas of data analytics, soft computing, evolutionary computing, machine and machine learning, deep learning techniques. She is broadly working on the applications of healthcare, finance, and network security. On the behalf of School of Electronics, IEEE Signal Processing, KIIT Student Run, welcome you, ma'am, and hope the students and the faculty members present here will get a idea, or you can say you can get a specific points, problem statements in research.
Thank you, ma'am,
Ma'am,
for giving me this opportunity. Hello, am I audible?
yes,
yes, ma'am. You are audible.
Yes, now can I share my screen?
Yes, ma'am.
Is it visible?
Yes,
Hello.
ma'am.
So good evening to you all. And today's my topic is recent trends and applications of machine and deep learning techniques. Okay. So though I will cover very fundamental things, so you must be knowing about this, but still I am going into the detail so that you can able to understand. And the overview of my talk will be divided into three categories. First one will be intelligent data analytics. Second is fundamentals and applications of artificial intelligence. And third one is deep learning techniques. So first part A will be intelligent data analytics. So first of all, we have to go through the data. First, without in machine learning, without data, we cannot do anything because it is completely depending upon data. First of all, we have to download the go analysis of the data, what is there in the data, and the type of the data, and like tabular data or text data or image data or signal data or sound data. There are different types of data are there, image data. Then after that, we will discuss about the steps of data analysis, then types of decisions or operations or actions, then computational intelligence, then AI or ML techniques, then decision making. So first, when we will discuss about data, first we have to analyze the data for having the decision making. Decision making means reasoning and arriving at a particular solution. It requires some analysis of the data. Basically, it is of two types. One is statistical, means when we are doing in chi-square test, F test, ANOVA. These are basically statistical tests. Now we are discussing about intelligence based on computational intelligence technique like AI, machine learning, like artificial neural network, multi-layer perceptron, then fuzzy logic, then deep neural network, then generative AI. These are basically intelligence based CI techniques. Then we are discussing like a buzzword, big data analytics. So what is the meaning of big data? So it is used for both statistical as well as the intelligent methods. Now you see, the steps of data analysis is very very important when you are doing some research. First of all, we have to download some data, and one thing you people must be remembering that when you are doing the research on a particular topic, unless if you are not finding any data, don't go or use that topic, or um, rather you have to choose next topic. Suppose for example, I want to go like in weather monitoring, but I am not getting the standard website or dataset details in any of the websites or GitHub like websites what we are using now. So don't choose that area, because when you are doing or writing some research paper, you have to think that the data set should be standard, and that data set when you are downloading some research paper, most of the research papers would have been used that data sets particularly, then only you can able to use that data set. Otherwise don't use that any other data collecting from our meteorological department from Orissa, don't use that one. Why I am telling to you, because when you will be collecting some data in Orissa, or particularly in healthcare sector, if I will go and collect some data from some hospital or Apollo hospital, but when our paper will go for review process in foreign countries, they will not know about the some hospital and Apollo hospital. So they must search about the standard website like UCI, like Hugging Face, like NIH, so Kaggle. So these are the standard website which all the papers they are using. So when you will use the standard data, when you are writing some project, government funded projects, then only you can use our agriculture data, ICAR, or medical data, ICMR. You can use those data. So data is very, very crucial for the machine learning because it is completely a machine dependent. Why? Because we are having some algorithms and the input is completely data, and output is also we are getting like decisions. Binary class, either 0 or 1, multi-class 0, then 0.5, then 0.9. So while you will be getting the output like binary class 0 and 1, don't take 0 and 1 because they are like absolute values. When you are downloading some data set, in the data set, all the values are in the form of decimal. None of the values are absolute values. So that is why when you are taking like two class, heart disease or no heart disease, COVID or non-COVID, cancerous or no cancerous, at that time don't take 0 and 1. Convert that 0 to 0.1, convert the 1 to zero point 0.9. That is called as nearly called as 0 and 1. Why? Because this is a machine learning. Machine learning is completely based upon soft computing. You must be knowing about what is the difference between soft computing and hard computing. If you don't know also, I will clarify. Soft computing means 2 into 3. Previously, when the school teacher used to say like, please remember from 2 to 25 table, you people are remembering like, yeah, 2 into 1, 2, 2 into 2, it is 4. So those values are called as 2, 4, 6. These are called as what? Your hard computing. Okay. When now, if someone will ask to us that is what is 2 into 1, you can say it is 1.9. So when you will be saying 2 into 2, it is 3.9. So it is also correct. That means it is soft computing. So that means it is in point approximation. Zero point 0.5, it is decimal value, it is point above zero point 0.5, we have to round up to 4. Below zero point 0.5, we have to round up to 3. Cell and fluid function. So here so many things are there beside machine learning. And here we are having the first of all pre-processing of the data, generation of machine data. We have to find it out the how many machine values are there using NaN in my Python that a number. And if we are having any data and if the data set is tabular or textual data, so you can add some numbers into it. That when it will be the data set will be a categorical data, then we cannot add any numbers to it. Then normalization of the data. So normalization means what? Suppose we are having so many data sets. Suppose in a class we are having different age groups. So means some student will be having 30 higher amplitude, that magnitude. Someone will be the lower one. So how my model will understand that that person's age is 45, that person age is 20, that person age is 50? How? So in order to make it balance, we have to go through normalization. What is the meaning of normalization? That means all the values, irrespective of higher value, higher magnitude and lower magnitude, all the values should be equal. That means in one range. That is called as what? 0 to 1. That means you must not think like whose magnitude. That means one student age is 25. His age is highest. That senior one. But you don't think like 25 magnitude will contribute more rather than 18. So in order to make it balance, we have to go through 0 to 1. That means all the magnitude will be equal. No higher magnitude will contribute maximum, no lower magnitude will contribute minimum. All should contribute equally. That is the meaning of normalization. Different type of normalizations are there, like min-max normalization. We have to take one data point x minus x minimum divided by x maximum minus x minimum. Another one is you have to take x minus mu, okay, mean divided by standard deviation. That is also another type of normalization. Then coming to feature extraction. What is the meaning of feature extraction? Basically, there are three types of feature extractions are there. Like again, we will discuss like why the feature extractions are important. What is the meaning of feature selection? So many things are there. We will discuss. Feature extraction means suppose there are two twin boys are there, and how the mother will know that he is Mr. X and he is Mr. Y. Suppose out of two, One will be having the black mole at the right side of the head. One is not having. One will be wearing some wristwatch. Another boy is not having. So this is the meaning of a feature. So features are of three types. One is statistical feature. Statistical means mean, variance, standard deviations, kurtosis, cumulant. These are type of different types of statistical feature. Transform domain features like discrete Fourier transform, wavelet transform, cosine transform, S transform, Stockwell transform, Slanklet transform, Vinograd transform, rectangular transform. So many transforms are there. Those transforms can also be used as feature. So if you want to do some research, then take the transform domain features as the feature of your problem. Suppose you are using CNN, but the feature will be DFT. Feature will be Webley transform. Then your paper will get published. Technical feature. What is the meaning of technical feature? Suppose some students are working in stock market. Some students are working in weather forecasting. Some students are working in bankruptcy prediction. The data they are collected or the data they are collecting that is pertains to those type of problems. Because suppose I am doing the research on stock market, the data that I am collecting that is stock related data. That is called as technical feature. Suppose I am working in heart disease, the data that are getting collected from the website that is heart related data. That is called as what? Technical feature. Feature reduction is what? Factor analysis, principal component analysis, linear discriminant analysis. So there are different types of feature reductions are also there. Another one is there like independent component analysis ICA. So why we are using feature reduction? That means suppose the dataset is too huge and large and the features are more and the researcher wants that some features to be reduced. So at that time you will be using feature reduction. So the most of the researchers they don't want to use feature reduction techniques. Why? Because some important features are also getting reduced. That is very crucial that there will be 100 number of features are there. But if I will be using PCA or LDA, then whichever important feature will be reduced, I cannot know. That is why while choosing the feature reduction technique, it is very crucial that which important features you have to keep. So you should be in touch with that. Means some important feature can also get reduced. So that is why we people are are avoiding the use of feature reduction techniques. Then coming to decisions. So whoever we are doing the research on this area like ML, DL, anything else. So basically there are of different types like 8 types. First one is filtering. Okay. So what is the meaning of filtering? Suppose I am saying some words to you and you want to make record of my voice, but after some times after record is over, you want to listen my voice, but my voice the clarity of my voice is not there. What is the meaning of that? So then you want to use you want to remove the unwanted noise from my voice. That is called as a filtering. Okay, is clustering. Clustering means the group of students are present based upon the similar criteria. For example, when when I we will be saying that yes, the students secure that above 80 to 90 in previous semester, they will be categorized into one group. That is called as a cluster. So clustering are of various types like K means clustering, hierarchical clustering, fuzzy C means clustering, density based spatial clustering. Different types of clustering are there. But while discussing about supervised and unsupervised, clustering is coming under unsupervised. Okay, so you must be knowing about that. In many of the competitive exam, you will be getting the questions like whichever following is supervised. So first of all, supervised means classification. Why classification is supervised? Because in supervised, one teacher will be there to teach. So that means in my data set, there will be no teacher, but there will be one target class. That means 01, like iris flower sheet. In iris, there will be 150 flowers, 4 columns. Last will be what? Species class. Am I audible or not? Hello.
Yes, ma'am.
So you are getting it clear or not?
Yes, ma'am. Yes, ma'am. Clear.
So actually, in class, like in classification, we are next point is classification. When we will be discussing about classification in my data set, when we are talking about iris flower, and the last column is what my species class. What is the species? Species is of three types: Virginica, versicolor, and Setosha. So that means the flower is grouped into which species. That is the meaning of a clustering. So forecasting. What is forecasting? Suppose today's stock price. I know I have past 10 days stock data, but I want to predict the 11th day. So actual value I will be giving to my model and will be predicted the values for tomorrow. So the error I will be getting like actual value minus predicted value. That is our error term. Okay, that is called as forecasting or prediction. Suppose I went to doctor. Doctor gave me prescription. Yes, do this test, do that test, ECG, MRI, this test. But same input I will be giving to my AI model, and AI model will be telling me that the same thing that yes, you are suffering from this disease or that disease. So that is the meaning of what forecasting prediction. And I will match with my doctor's report and my report, which two are correct. Okay. So we cannot replace the doctor, but we can assist the doctor. Is it clear? So then coming to classification. So classification means so when there will be heart disease or no heart disease, the two class. When there will be multi-class 0, 1, 2. That means no heart disease, less heart disease, then prone to heart disease. That will be a what? Three class. So here we are having the multi-class problems. Okay. Then coming to parameter estimation. And what is the meaning of this parameter estimation? And the idea is to what to adjust this parameter so that the model become as good as possible to predict or explain the actual observation you have. Suppose means we are having like a parameters. What is the meaning of parameters? Parameters which has been fixed implicitly and hyperparameters are used by the researchers. For example, when we are doing hyperparameter in neural network input that has been fixed, weight fixed. Hyperparameter in weight updation rule, you are using learning rate, mu or gamma or alpha. That is 0 0.1, 0 0.01, 0 0.00001. So the hyperparameter value has not been written anywhere. The user will take from his or her own. That is the meaning of what? Hyperparameter. What is the meaning of parameter then? These parameters you have to do adjust so that your model should perform as good as possible for predicting or explaining the actual observation. Then coming to inverse modeling. So inverse modeling is also called as inverse problems or the convolutions, channel equalizations or nonlinearity compensations. It refers to what the process of determining the input parameters or the condition of the system by analyzing its observed output or the response. So it is working backward from the observed data to find out or to get the what are the factors that produce those observations. Then coming to optimization. What is the meaning of optimization? It is maximization or minimization, single variable or multivariable, single objective or multi-objective, with constraint, without constraint. We will read like if I will have time, I can discuss one of the optimization algorithm like genetic algorithm. I can solve that problem, then you can able to understand what is the meaning of that. Detection means whether that is present or not. But in case of classification, whether it is of different class or not. But in case of detection, whether that object is present or not. That is the meaning of what detection. So there are a lot of techniques that are available for different types of operations. For filtering, you can use least mean square or recursive least square and back propagation techniques. Then feature reduction, PCLDA, clustering, different types of clustering algorithms are there, like K-means clustering, hierarchical, fuzzy Siemens. In case of forecasting prediction, you can use regression, logistic regression, nonlinear regression. So what is the meaning of regression? Regression means to predict the continuous values. Suppose rainfall prediction, to predict the salary, to predict the age. That means salary means what? We have to keep record of the every month's data. Then only we can go for use of what? Regression. That means to predict the continuous values. Classification means it is discrete. Yes, no, true, false. Spam mail, no spam mail. So here also we are you can use different types of classifiers are also available like naive Bayes based upon Bayes theorem, decision tree, random forest, support vector machine. So many types of classification techniques are there. Parameter estimations are also LMS, RLS, ANN, plan, functional link, artificial neural network, inverse modeling. Then in optimization, most of the time we will be using the biological inspired technique, nature inspired techniques, or evolutionary computation techniques. Detection also we can use bioinspired techniques or ANN. Then distributed learning, it is of two types, incremental as well as diffuser. Then coming to what is the meaning of intelligent system? First of all, intelligent systems are divided into different types like fixed system, then adaptive system, then after that intelligent, smarter, cognitive. So what is the meaning of fixed system? Fixed system doesn't learn anything and doesn't change its behavior after deployment. So here for fixed system we are having the rules. That means predefined rules. For example, you can have like calculator. So we are having the some predefined rules are there. We will give us input, then we will be getting as the output. And then after that, what is the meaning of adaptive system? In case of adaptive system, it can exist itself based on the new data or the if the environment gets changed. So what is the meaning of this? Suppose learning of the data and update the parameter. So this, for example, like adaptive noise cancellation. So when you will be using this here also we have to go forward adaptive systems. Then after that, what is intelligent? Intelligent system means what? It can learn, it can reason, it can have the decisions, it can solve the problems. For example, like ML and AI algorithms. So it can generalize to unseen data. So that means this is called as what? Intelligent, smart, or cognitive. So then after that, computational intelligence. So basically, computational intelligence are divided into three parts. One is ANN, like perceptron, multi-layer artificial neural network, plan are of various types like exponential plan, cheb-by-cheb plan, then polynomial plan, trigonometric plan. So many types of plans are there. Radial basis function neural network, it is very simple neural network, and here we are using basically different types of kernels, and kernels means we have to change from the one dimensional space to different dimensions. And in case of regular basis function neural networks, there are different types of kernels. For example, Gaussian kernels. The most widely used kernel is Gaussian kernels. Recurrent neural network is a type of LSTM, long sector memory. Spiking neural network is emerging topic. You can use your in your research work the spiking neural network. Nobody has done this type of research in spiking neural network, and there are different types of spiking neural networks are there like saffron session, and you can use this type of neural network in your research as well. Then convolutional neural network. In case of convolutional neural network, there are two types. One is convolution, another one is neural network. Convolution is used for the feature extraction. Neural network is used for what? Classification. Then second is we are having different types of operations. First one is training, second is tasking or validation. What is the meaning of training? Training, there are different types of schemes are there like 80, 20, 70, 30, then K-fold. So basically when you someone will ask to you like what is the difference between 70, 30 and 80, 20 and which one is better? Okay, so you will be, what is your answer? Your answer should be like 80-20 will be better. Why? Because in 70-30, we are using 70% of the data is for training, 30% for testing. But in case of 80% and 20%, 80% data are used for the training and rest 20% data are used for testing. No doubt, in case of 80% and 20%, you are having more number of data than 70-30. So no doubt, usually 80 and 20 will be better than the 70-30. Okay. So here, in case of supervised, we will be used for the past or old data. Suppose we are, if I will download the stock market data from yahoo.com, I will be getting the old data. So that is my what? Supervised learning. Unsupervised learning means no training data is required. Suppose learning of the bicycle. When a baby is learning a bicycle for the first time, no teacher is there. That means he will learn, he will fall, again he will learn, again he will fall. That is the meaning of a super unsupervised. Okay. And reinforcement learning, it is basically a agent based learning or the reward based learning. Suppose there are in a one floor there are 10 rooms are there, and in one of the rooms I will be keeping fish or milk. Then my agent is cat. So cat will go to each and every room till it will find the food. If it will not find the food, then penalty. If you will find the food, then reward. So that means my environment is my what? The rooms in one floor. My agent is what? Agent is having, agent is my cat. Agent is having actuator. What is actuator? Like input and output devices, like sensory devices. So that means it will percept that in which rooms I am having the food. In that rooms I will go and I will take the food. Then this part is training. Rest part is testing or validation. That means 80%. Suppose I am having 100 samples. Samples means rows. Okay. You have to take random. Generate a random number. Random number lies between 0 to 1. It will never be repeated. It is always positive. Okay. So you have to generate a random number. Suppose 25. Multiply with, you have taken the 80% of the 100. Okay. Multiply with the total number of data. Can take the integer part. Okay. Suppose it came like 20.25. Then discard 0.25, take the 20th row. Okay. Similarly, it will go up to what? 80% because you have given the condition like 80%. The remaining 20% which has been left, that is used for what? Your testing or the validation. But some students, what they are doing, like suppose 100 means they are taking sequentially from serial number 1 to 80, and rest from 81 to 100 they are keeping for testing. If you will do in that case, what will happen? The model will be biased. Means that model will only work for you, not for me. But if you will be taking generate a random number, then multiply with total number of samples, 100. Take the integer part. Similarly, you have to do forward 80 times. Then only that model will not be biased. That model will work for everyone. Okay. Next one is what? Fuzzy logic. Fuzzy logic, you must be knowing that it is proposed by Lotfi Jagge in 1965. It embodies like human-like thinking into a control system. There are different types of fuzzy logics are there. Takagi Sugane, T.S. Fuzzy, Mamdani Fuzzy, and the most recent one is most of the time they are using like rough fuzzy set. And next is biological inspired technique or nature inspired techniques or evolutionary computing like genetic algorithm, differential evolution, particle swarm optimization, cat swarm optimization, ant colony optimization, and bacterial foraging optimization. These techniques are basically a derivative free learning. And previously, what we have discussed, these perceptron, multi-layer, artificial neural network, these are completely what derivative based. We are having derivatives. But for this optimization, we do not use any derivatives here. So this is called as what derivative free learning. So here in these techniques, we will be using like minimization and maximization. These are basically we are these algorithms we are using for like nature. From the nature, we can use daily one by one techniques: fish algorithm, blue whale optimization algorithm, penguin algorithm, cockroach algorithm. Every algorithms that is coming up because of the nature. From the nature, we are studying its character and we are doing it. So these are a few examples of AI or machine learning techniques based upon the quality of services where we are using these machine learning techniques like spectrum management, channel estimation, classification of wireless signals, multi-objective routing optimizations, resource allocation, massive IoT management, secure link assurance, autonomous drives. These are different types of examples where we are using the decision makings and quality of services in AI and ML. So here examples of decision making in clustering we can use k-means or hierarchical classification. Various types of classifiers are available like naive Bayes, decision tree, random forest, SVM prediction. You can use SVM, logistic regression, plan, and RBF. Optimization and nature inspect technique, single objective GA, differential evolution, PSO, multi objective. We can use like NSGA2. Feature reduction, PCAD, unsupervised learning is one biggest example is for reinforcement learning. So here coming the different types of learnings are there: supervised, unsupervised, and reinforcement learning. Basically, supervised learning is working upon the labeled data set. Okay, and the biggest example is like spam email detection and get stock market data. And unsupervised learning means we and for supervised we are having like classification is one of the most example that classification is a supervised learning. Unsupervised learning is like it involves the training of the model on unlabeled data. That means there are no predicted output or the categories. So here we can use like clustering, customer segmentation. Reinforcement like is a goal-oriented learning technique where an agent interact with an environment and learn to make the decision by receiving the reward or the penalties for its action. Example like self-driving car and uh, then game playing. Then different types of training and testing schemes already we have discussed. So here, in case of 70-30, the data sets are divided into 70% of the training data, rest 30% used for testing data, and model will be learned from the 70% and is evaluated on the remaining of the 30%. Similarly, in 80-20 also 80% used for the training and rest 20% used for the testing. Another one is that is K4. So if you are doing in any of the research, you can use like K4 cross validation. What is the meaning of K4? Like if suppose the K is 3, suppose there are 150 flowers. Randomly, you will be taking the 50-50-50 flowers in three of the groups. After that, what you will be doing, first 1 and 2 will be taking for training, 3 cluster will be testing. In second iteration, 2 and 3 will be training, 1 will be testing. In third iteration, 1 and 3 group will be training and 2 will be testing. After that, make it average to, to get accuracy, precision, recall. That is the meaning of what? K4. So K can be 3, K can be 5, K can be 7. Is it clear? So out of the three types of splitting schemes, K4, the K is 3, the best type of training and testing scheme because the developed model generally degrade the performance in case of K4 compared to 70-30, 80-20 based training and testing schemes. So if you are getting the good result in K4, definitely the out of these three, the K4 will be the good one. So while doing the research, so how to draw the block diagram of the training of the models and testing of the models. So suppose if I'm going into like in Healthcare. So the input will be either image data, case attribute, or 1D signal or 2D signal. First of all, I will be feeding this data into my model, and the first step is what? Either I will go for feature extraction or selection or reduction. Okay, so select feature extractions you can use by statistical method, technical method, transform domain method. Feature selection, wrapper method, embedded method, filter method. These are different types of feature selections are there. Feature reduction, you know very clear, that is PCA, LDA, ICA, factor analysis. Then you have to apply any of the classifier, naive Bayes, SVM, decision tree, random forest. Then you will be getting some predicted class. Then you have to sum it. Then some desired class will be given to you. So again, you will be getting the error. That means actual class minus predicted class will be getting like predicted class minus desired class, or actual class minus predicted class will be getting the error. After that, what you will be using some learning algorithm to update the weights. This ML classifier is not a block diagram. This ML classifier you will be using like what? Some neural network. The classifier. Those output you have to give here. And suppose stock market data. Stock market 10 days data you are giving here. You want to predict 11th day data. Those 11 data will be feeding over here. The 11th data minus 10th day data, you will be getting the error. That is the meaning of what error term. This figure is for first A figure. This is for training. Rest, this is for testing. Testing means in training you have to calculate error and update the weight. But in case of testing, you have to check whether you have successfully training is over or not. Only you have to give the signal, feature extraction, selection, reduction already you have used. You have to use the ML class and you have to predict the class. That's it. Then this is the IoT. IoT based sensors subject are required to the different types. Subject means here we have taken like patients. Here we have used the network infrastructure like operating systems, wireless protocols, security algorithms, gateway, cloud infrastructure, medical history of the subject's data collection. Then again also we have used feature extraction and reduction. Same ML classifier, predicted class, desired class, again error and using learning algorithms and update the weight. This is for IoT based. Means, for example, if some patients that are village people, they are staying in village and they cannot come to Bhubaneswar for any type of treatment. So we have to use like IoT, Internet of Things. So that means what we will be using, deploy the sensors so that we can get the data of the patients and we can look it out that in our hospitals. Then this is the most important means techniques and which most of the researchers they are going to use right now, like ensemble models. So ensemble models means what? What is the meaning of ensemble one? Here, previously in ML, we are giving only one data set, one model, we are working on that. But here you see here only one data set, but parallelly two models. You can use parallelly 3 to 4 models, no problem into that. Two models, ML, two models, DL also you can work. Here you have to get the accuracy, and this accuracy has some weight W1 and W2. This will be summed up. This will give some output, and the desired output I will feed into here. Predicate class minus desired class, I will be getting some output. Then through any type of optimization algorithms, we have to update the weight. This is the meaning of an ensemble model. Suppose you have taken 2 ML model, 2 DL model. Total is 4. Out of this 4, from 2 ML model, one will be rank 1, giving highest accuracy. From 2 DL models, one will be giving the highest accuracy. Those two models, you will be using this in ensemble model to keep the model in parallel. So that is why that is called as an ensemble one. Though you have taken 4 models, and how to know that among these 4 which one is 1, 2, 3, 4. For this ranking, we are having one method that is called as a toposis. So the toposis is used for ranking of the methods. We are manually, as the number of methods is very less, like 4, we are ranking them as 1, 2, 3, 4. Suppose if you are taking the 10 techniques, you can use, don't use manually, you can go for what? Toposis. Okay. This is the meaning of what? Ensemble one. Then I will discuss one of the optimization techniques, though we are reading like optimization, maximization, and minimization, but here we are having lot of optimization techniques. But I will, if you are having time, then I can discuss one of the optimization techniques that is called as generic algorithm. So here we are having lot of optimization techniques like GA, PSO, CSO, DE, differential evolution, and colony optimization. All are derivative free learning. Okay. So basically, what is the genetic algorithms? It is divided into three parts like ANN, fuzzy logic, and computational intelligence is divided into three parts ANN, fuzzy logic, and evolutionary computing. Already we have discussed. It is an optimization problems. Either it is a maximization or a minimization. And here the optimization means single variable or multivariable. Single variable means f of x is equal to sin x. Or x is single variable. F of x is equal to sin x1 plus cos x2. That means it is a multivariable. Single objective or multi-objective means single objective f1x sin x1 plus cos x2. Maximization f2x e to the power minus x1 plus tan x2 for minimization. And with constraint, without constraint means here we are having some constraint, that means y equal to sin x. Maximization, we are having a constraint, and as x will be lies between 0 to 2 pi. This is the meaning of a constraint. So if we will not give any constraint means a condition. If we will not give any condition, that means it is called as what? Without constraint. So here, first of all, in case of GA, you will not get a single set of solutions. You will be getting the large set of solutions. That is in a particular curve. Okay, the curve is called as what? Pareto optimal curve. Some of the optimal solutions that will lie in the curve that is called as optimal solution, and some of the points that will not lie in the curve that is called as what? Non-optimal solutions. Okay, so here basically there are two types of representations of GA, like binary coded 0110, like this binary coded. Real coded means that is in decimal, in negative that is called as real coded. So we will discuss about like binary coded. It is a first of all, genetic algorithm is a population based learning algorithm. Here we will take population size. So initially the set of solutions to be assumed, and here we have taken the population size is 50. For population, to decide the population size, no rule is there. You can take as much you can. If the number of variables is more, population size is more. Otherwise, for one variable, the optimization population size will be either 30, 40, or 50. What is the meaning of variable? If y equal to sin x, here one variable you can take either 30, 40, or 50. If you are having more number of variables like sin x1 plus cos x2 plus tan x1 x3 like that, then you will be taking the more number of population size. Each member of the population size is called as solution X. Okay. Here we will discuss like binary GA. In binary GA, each chromosome comprises of the number of genes. That is 1 and 0. This A1, A2, A3, A4, that is called as what? These are like chromosome. Okay. 0, 0, 0, 0, all are like chromosome. It can be either, usually the number of genes in a chromosome is either taken as 8 or 10 binary bits per variable. The 0 is called as what? One gene. This one is called as one gene. So combination of all the chromosomes that is called as what? For population. So that means if you are having the 10 number of chromosomes, the population size is 10. If you are having 20 chromosomes, that is population size is 20. Okay. But these bits should be either 8 or 10. Okay. For example, you see here. If my y is equal to sin x1 plus cos x2, the number of variables is how much? 2. So the length of each chromosome will be what? 2 into 8 equal to 16 bit. So one variable chromosome, here you see 100100111, anything. That means it is at like 8 bit. So here having two variables, so it will be like 8 plus 8 totally 16 bit. Is it clear or not? First step, there are different 5 to 6 steps are there for GA. First one is what? Initialization. In case of initialization, the number of chromosomes I have taken like 50 population size, that is in assumption. Each chromosome size is what? That is in 8 bits. That is gene. First step is what? Step 1. You have to take a generate a random number. Random number lies between 0 to 1. Yes, am I audible?
Yes,
Yes.
it is audible, ma'am.
Hello.
Yes, it is audible.
Okay. So are you understanding what I am saying, or you are not understanding? You can ask me any questions.
Yes, ma'am, we are understanding.
Okay. So step one is what? First you have to generate a random number. A random number lies between 0 to 1. And you have to take subtract the zero point 0.5. 5.5 because it will lies between positive numbers, positive range. If the answer is positive, then assign 1. If the answer is negative, assign 0. First, repeat the step 1. That means the step 1 8 times. Why? Because each chromosome is my what? 8 bit. And step 3, repeat step 1 and 2 50 times. Why it is 50 times? Because the population size is what? My 50. Then coming to crossover. Crossover means there will be parent and children. So there are different types of crossover are there. Single point crossover, that means two or 2 point or multi-point crossover. If the number of variables are more, we can go for multi-point crossover or 2 point crossover. If the number of variable is one, we can go for a single point crossover. Here you see crossover point. That means there are parent one and parent two. These parent one and two will produce the two child one and child two. Okay. So here you see 1010, then it will crossover with second. First half will be crossover with the second half 101. This first half 011 will be muted with crossover with 0101. You see here 2 point crossover first. For crossover, we are having some probability like called as crossover probability. Crossover probability is denoted by PC. So PC that is lies between zero point 0.8 to 1. So here we have taken like point crossover probability is zero point 0.8. So the number of chromosomes which will undergo, that means total number of sample is 50 and the crossover probability is how much? 0.8. That means 50 into zero point 0.8 is how much? 40. So the population size in the crossover probability, so the 40 chromosomes will constitute 20 pair. Why? Because it will be parent 1 and parent 2. Crossover will produce the two child. Okay. So out of 50, 40 will go for what? Crossover and rest 10, they either they will not marry or they will be remaining as bachelor. Okay. See here. Total is 50. Total sample is 50. After crossover, you see 40 chromosome will crossover. So 40 means 20 pair. Okay. So here I have to calculate. I have taken the function y equal to sin x. So first I have to calculate, evaluate y1 to y40. So convert each chromosome from binary value to decimal value. You know very well how to calculate binary value. Binary to decimal 1010, 0 into 2 to the power 0 into 2 to the power 1, then 2 to the power 2, then 2 to the power 3. So you will be getting the value like 10. Okay. So then you have to go forward, put each value of x here from 1 to 50 into y equal to sin x. So you will be getting how many 50 values of y, because sin x1, x2, x3 up to 50. So order y from the highest value to the lowest value. If you are taking the maximization, if the function is maximization, then x highest value of x to lowest value means descending order. If you are having minimization, then order them from the lowest value to the highest value. Then first 40, 50 into zero point 0.8, which is 40, that means 20 consecutive pair will get crossover, then the remaining chromosomes will not get crossover. Then process of crossover, how to take single point. The why I have taken a single point, because I am having only one variable like y equal to sin x. So you have to take the first pair of P1 and P2. What is P1 and P2? Parent 1 and parent 2. Each has 8 gene. So you have to generate a random number. Random number will be multiplied with 8, and we have suppose we have to take the integer part. Suppose it came like 5. So I have taken 5, you will be taking your answer will be some other. Why? Because random number is different. 100 times if you will execute, random number will never be repeated. Okay. So when see here process of crossover, P1 and P2 parent 1 and parent 2 will produce C1 and C2. So suppose crossover bit I got, after fifth bit I got the crossover point, single crossover point, that is for P1 and P2. This 5 bit of P1 then will merge with the 3 bit of P2. This 3 bits of P1 will merge with 5 bit of P2. Then it will produce the two child C1 and C2. Then process of crossover, repeat the previous step for the remaining 19 pair. Why 19 pair? Because we have already got 20. 50 into 0.8, that is 40, that means 20 consecutive pair. For each one I have to calculate. It means one I got calculated P1 and P2, then after that it will be repeat for a 19 pair. After the process is over, 20 pair of parents, that means 40, 20 pair of children also 40. So 10 numbers not undergone crossover. So the new population size is how much? 40 plus 40 plus 10, 90. That means initially my population size was how much? 50. But now my population size has been increased from 50 to 90. Now I will go for what? Mutation. Mutation means that mutation probability PM is very small. The PM lies between 0 to zero point 0.2. And let the mutation probability is zero point 0.2. All the 90 will undergo mutation, not 50. In crossover, 50 was there, but here all 90. That means 90 into zero point 0.2, that means 18. Okay. So here randomly we have to choose a chromosome out of 90. That means 40, 40, 10. Then integer part means some random numbers. Okay, random number multiply with total. Suppose I got here 20. Now what to do? I will directly go to chromosome number 20, choosing a randomly a gene, generate a random number, multiply with 8. That means number of bits of the chromosome. Take the integer part, suppose it is 4. Then go to fourth gene of the 20th chromosome. If it is 1, make it 0. If it is 0, make it 1. Mutation is simply just like this. Suppose I have it is up to 20th. Why? Because 19 to 0.8, 18 numbers. Then after that, suppose I got generate a random number into 90. Suppose it became 20.02. So decimal part I got, it will be cancelled. So I will be having what? 20. So when I will be having 20, I will directly go to 20 chromosome. Then I have to choose the gene. Chromosome means what? 101010 up to 10. The whole is called as what? Chromosome. Gene means what? One cell of the chromosome, that is called gene. Then I have to again multiply with, though my chromosome size is what? 8. So generate a random number, then the multiply with 8. Number of bits of the chromosomes. Take the integer part, suppose 4. So this entire part is called as what? My chromosome. One cell is my what? Gene. So then what I did, I will jump to 20th chromosome. Then after that I go generate a random number, multiply with 8. Take the integer part, suppose it is 4. So the fourth part of this chromosome will be what? This 1. If it will be 1, flip into 0. If it will be 0, flip into 1. If one chromosome is over, repeat the above steps for the 17 times. Why 17 times? Because previously we have calculated like mutation probability zero point 0.2 into 1918. So we have calculated for 1. Rest similarly for 17 times we have to calculate. So after the mutation process is over, then the selection process will start. So the total number of chromosome is how much? 90. Evaluate the fitness of each 90 chromosome. So function y equal to sin x is to be maximized. If you can also take minimize. Convert each 8 chromosome into decimal value from x1 to x90. Put each decimal number x1 to x90 into the function, that is y1 yi equal to sin of xi. Xi means I varies from 1 to 90. So evaluate y1 to y90 means if I am calculating y equal to sin x1, that means x1 means for first y. Similarly, I will be getting the 90 times. So though it is a maximization problem, order the chromosome in terms of the corresponding highest value to the lowest value. So first keep the 40, keep first 50, discard the rest 40. Okay, so here our generation 1 is over. Similarly, I have to start with second generation. Again, I have to go for crossover. Then select 40 chromosome, descending order of Y, repeat crossover, repeat mutation, then retain 50 chromosomes, then take the best 50 Y values. So where to terminate? After few generation you see, all the 50 chromosomes should be same, but it takes more number of generations. Generation means for generation 1 you have to calculate, for generation 2 you have to calculate. Then after some generation you will see that uh, in 2 consecutive generation there will be very less number of means variations. There you have to stop it. So the alternative method is what? At the end of each generation, choose the Y value of the first chromosome, find the first highest value of the Y in the next generation. Then if the change in the highest value of Y in two consecutive generation is very small, or 1% or 2%, then you have to stop the repetition. This is the termination process of the genetic algorithm. The first, the always best chromosome in decimal form it represents the optimum value of x. If this value of x will put in y equal to sin x, then the corresponding y will be the what? Highest value of the function. So the ideal answer is what? X equal to pi by 2 and y equal to 1. So but in the practice you will be getting the very close to 1. So here the algorithm is over. Why? Because y pi by 2, because we have taken y equal to sin x function. So what are the applications of GA? Basically we can use for the optimization and numerical and combinatorial optimization problems like TSP, traveling salesman person, routing of the graphs, coloring of the graphs, partitioning of the graphs, robotics, trajectory planning, machine learning designing like neural network classification and prediction problems, weather or protein structure, signal processing, filter design, design of the semiconductor layout, aircraft design, communication networks, automatic programming evolved computer programs like specific task design, cellular automata, sorting of the networks, economics, immune systems, and ecology. So, so we already discussed about different types of feature extraction like statistical features, structural features, image transformation features, and hybrid topological features. Classification like ANN, software vector machines, hidden Markov models, quadratic discriminant functions, nearest neighborhood classifiers, deep learning and convolution neural networks. And part B, somewhat I kept like fundamentals and applications of artificial intelligence. So you know very well that everywhere we are talking about AI, ML, neural networks, and deep learning. So don't tell like AI is something different than ML and DL because everything is AI. AI is like an umbrella under which machine learning is a subset of AI and neural network is a subset of ML. Deep learning is a subset of neural network. So that means all we are discussing about AI. Don't tell about I am working in AI, I am working in ML. So ML is not your area. ML is just like a tool. Okay, machine learning. Don't tell like my if someone will ask like what is your in which area you are working. Don't tell ML because
Ma'am,
huh.
ma'am, maximum
Hello.
Ma'am, your voice is cracking.
Now it is clear. Hello.
excuse me, ma'am.
Huh. Hello.
Ma'am, your voice is cracking. You're not audible. Could you please write in the chat? It would be
Now it
better.
is audible.
Yes, ma'am, you are audible.
Okay.
Rashmita ma'am's
So
voice was cracking.
okay. So here the relationship act between AI, ML, neural network, and deep learning is that AI is the umbrella of all. So whoever is doing the research in machine learning, don't tell about I am doing the research in machine learning because machine learning is not the area. Machine learning is a tool. In that, by using that tool, you can use in different type of field like healthcare, like cybersecurity, like cloud computing, like stock market, like financial market, like time series analysis. So by using ML, okay. So this is the overview of the AI, ML, and deep learning. Then coming about difference between data and feature. What is hello? Am I audible?
Yes, ma'am, you are audible.
Okay. So, what is the meaning of data and feature? Data is basically divided into two types. One is labeled data and the one is unlabeled data. So, labeled data means that include the label or the target variable that a model is trying to predict. Unlabeled data means which do not include any label or target variable. What is the meaning of label or target variable? When we are downloading one data set, like healthcare data, the last column of the data will be having the target class, either 0 or 1. So that means that is called as what your target class. And when you are having the uh, don't have any target class, that is called as what your on label data. So data can be of three types: numerical values like case data, stock market data, rainfall data; 1D signal like ECG, EMG, PCG data; 2D signal like image, breast cancer, brain tumor, glaucoma, X-ray; 3D means that is video data. So if the number of data for the training purpose is large, then the features are extracted. Otherwise, directly the data is used as the input. But in case of 2D or the 3D data, mostly the features are used instead of the raw data. So here the data encompasses the raw informations collected, whereas the features are just very specific or the relevant attribute that is extracted from the data into machine learning models. For example, like consider a data set for the predicting the house prices. The data is like the complete data set containing the size, number of bedrooms, age of the house, location, previous sale price. But the features like specific column or the number of bedrooms, age of the house, location. So that means the data is like data and a feature is like a particular column. Different forms of the data are there, like numeric data that is measured in the numbers. Categorical data that means categorical feature is an attribute that can take on one of the limited and usually fixed number of possible values on the basis of the qualitative property. It is also called as a nominal feature. Ordinal means ignore the nominal value with the categories falling in the order list. Example include such as small, medium, and large measurement, customer satisfaction. So it is called as ordinal data. Feature selections are like we have already discussed, like topos and bioinspect techniques. So here we are having different types of methods are there, like filter method, wrapper method, and embedded method. Feature extraction we have discussed, like different types of feature extractions like statistical method, technical method, and transform domain methods. Here we can use like PC and LDH feature extractions, autoencoder and MFCC, male frequency substral coefficient. And why these are important? Because complexity of the models is very high. In order to make the low complexity, we can use the feature extraction and selection. Training time will be more if we will not use feature extraction and selection. Cost of the model will be more. To overcome this problem, features are extracted from the raw data. Amount of feature is much less than the raw data. So why these features extraction and selections are required? To improve the model performance, reduce overfitting, faster model training and inference, improved interpretability, and the difference between feature selection and reductions methods like when the amount of feature is very large and the handling of the large amount of the feature is very problem. So we have to reduce the feature. So there are different types of the feature reductions are there. But the disadvantage of feature reduction is that the original feature values are lost. New reduced features will be generated. We have no control on how many reduced features will be generated by PC or LDA. So difference between PC and LDA is like PC reduces the number of features but the class originality is lost. LDA reduces the features but the class originality is retained. So therefore the classification task the LDA is better. So how to split the data like training validation, you must know about that. I'm not going into detail. So what is the meaning of binary class and multi-class? Binary means two level of classification, yes or no. Multi-class means three class or more. Multi-class is same as multi-label. Class is same as label. For example, in a data set of hard digits, 14 test values corresponding to hard digits or no hard digits is given. For SG or no SG are called as labels. SG output may be three labels such as SG critical, SG medium, no SG. The data gives the labels in supervised learning like SG positive, SG negative, SG maybe medium. These are three labels. Pre-processing, this is very important stage of the classification. You know very well. Pre-processing helps in shaping the input so the training of the model becomes better. Shaping involves removing the interference, additive noise, which contaminates the data, generation of the machine data, removal of the instrument error or the measurement error, resizing of the image in case of image data. Advantages of data preprocessing is like it will model improve the model performance, better representation of the data, accuracy will increase, time will consume, error prone, limited understanding of the data. These are the biggest disadvantages. Normalizations, we discuss different types of normalizations. Activation functions, the in most of the neural network we are using activation functions like the prediction and classification models have to be nonlinear in nature. To achieve this objective, nonlinearity function needs to be introduced in every neuron, and activation functions introduces nonlinearity. Introduction of activation functions at one place of a neuron will not solve the problem, so the activation function is introduced in every neuron distributedly. This is satisfied by introducing one-sided and two-sided sigmoid functions. During intermediate computation, sometimes the result becomes negative. Such negative data may not contribute to the output of the model. So, to avoid this problem in each neuron, ReLU function is introduced. This function makes the negative data go zero. However, the amplitude of the positive data remains the same. Most of our prediction and classification problems are nonlinear in nature, like stock market data. So, if the final result needs both positive and negative, then two-sided sigmoid functions to be included in each neuron. And if the output data is required is always positive, then you can use the one-sided sigmoid to be included in the neuron. So here, out of all the activation functions, best one is either one-sided or two-sided activation function. They will give the better classification and prediction performances. And Hartley maker is used for the two-class problem in case where the output will be 0 or 1. You can use a Hartley maker. And ReLU will be used if you want only the output should be positive. You can use ReLU. And ReLU in each neuron makes the negative value to 0 but the positive remain as the same value. One-sided sigma is used as a nonlinear activation function. If the output we want only positive, that is between 0 to 1. And two-sided sigma is used as nonlinear activation function if the output we want both positive and negative, that should be between -1 to +1. This is a representation of binary escape function like f of x equal to 0, x less than 0, 1 means x greater than 0. Linear activation functions, this is the function for the sigmoid, one-sided sigmoid, 1 by 1 plus e to the power minus x. This is can hyperbolic, f of x is equal to e to the power minus x divided by f of e to the power x plus e to the power minus x. ReLU means rectified linear unit, negative value will be 0, positive will be as it is. And when to use which type of activation function, if you are having regression, then you can use linear activation function. If you can use binary classification, you can use sigmoid or activation functions. Logistic activation function, multi-class, softmax, multi-level, sigmoid, convolution neural network, ReLU activation function, recurrent neural network, CANH or sigmoid activation function. So this is the steps involved in data preprocessing, data collection, data preprocessing. It involves removing of the outliers, null values, missing values, data normalization, translating the data into range 0 to 1, data generation if we are having the less data through GAN, feature extraction, feature selection or reduction. Finally, the selected or the reduced feature are fed to the ML or DL models for the training, testing, and the validation purpose. So again, the parameters like the internal variables that the model learns from the training data, and in linear regression, the parameters are the coefficient or the slope or the intercept that define the linear relationship. That means y equal to mx plus c between the input feature and the output. This is parameter. Hyperparameters like the external configuration settings that are not learned from the data but set to the prior training process. For example, in a decision tree, the hyperparameter might include the maximum depth of the tree and a minimum number of samples required to split the node. That is called as hyperparameter. These are the parameters and hyperparameters are there. Then coming to AI. Yes, hello. So can I continue? Is there any time limit is there or should I stop? Hello? Hello? Am I audible?
Yes, ma'am, you are audible.
So should I continue or should I stop? Because what is the time actually? Means after 1 hour, so already time is over. So should I stop?
Uh, ma'am,
Rashmita
Savita
ma'am?
ma'am, yes, Rashmita ma'am, I think she, yes, ma'am, here she has joined. Rashmita ma'am.
Hello.
Yes, ma'am.
My voice is audible?
Yes, ma'am. Your voice is audible.
Madam, should I continue or should I stop? Hello?
Hello.
Hello? हाँ मैडम. हेलो.
So many domains you covered, it was really nice. Maybe because the students have a dinner time in our hostel, actually maybe that's why they may face some problems, so we can have another that. Covered a lot of things you told, though these are very common general things, but still there are many things which students do mistake commonly, like the very line you told, ML is a tool. So many a time
Yes.
students, even PhD students, tell that we are working on machine learning domain or machine learning topic. So many things you told. It was really very informative. So thank you, ma'am, from
Thank you, ma'am.
IEEE Signal
Ma'am,
Processing Society and all the
yes, ma'am.
students.
We have
Yeah,
a vote of
Subranil, you can give your feedback.
thanks session.
Yeah,
So
you can continue with that. Who will be giving that?
You or Rashmita ma'am can present the vote of thanks certificate.
Okay, so vote of thanks certificate, are you going to display?
Yes, ma'am.
Okay, so display that.
Please display
Rosmita
that.
ma'am, are you? Yeah, tell.
My voice is audible.
It is
Yes,
breaking
ma'am, it's
actually.
audible.
Uh,
Okay, Sarita ma'am, you can continue.
okay, so Adesha ma'am, we are really thankful to you for this nice and informative session. The certificate displayed is for you from IEEE Signal Processing Society, and I am sure you will certainly continue giving such valuable talks. And we are really interested to have part two of this lecture. So this certificate is for you, and we will be mailing it officially to you too. Thank you, ma'am.
Thank you, madam. Thank you, madam.
Yeah, so Subranil, any student or anyone would like to give some feedback, or can we end then?
Anyone has any doubt or any feedback?
Yeah, we
Any
can
questions
continue.
regarding this session?
Anyone, any questions? No, ma'am. I think we can.
We can stop. Okay. Okay, ma'am. Thank you then.
Okay.
Thank